All right. So, Assalamu alaikum, welcome back. So, what I want to discuss today is, let me see if I can make it bigger. What I want to discuss today is very, very critical topic, which is called Model-View-ViewModel architecture. So, I want to introduce it today, give you some example, and then you go to the lab, you will practice it, and then inshallah we'll come back and then finalize it and go through further details. Okay, so first of all, so as the complexity of our application grows, we need to be more organized, and we need to organize our implementation in a way that will make it easy for us to change the implementation, to keep the complexity under control, and to also make it easier to add more features, make it easier to do changes. So we really need to follow certain architecture, certain way of organizing our work. So one of the fashionable architectures out there that is heavily used now, both on Android, iOS, and also on the web, even on desktop, is known as the Model-View-ViewModel architecture, or summarized as model MVVM. Okay, so this model view MVVM, it's not theory, it's something very, very practical. And Android gives us some some component that will help us implement applications that follow this pattern, MVV pattern. We will see these components as we move forward, but to get started, these are the three critical components that comes with Android to help us implement our applications following the MVVM architecture. The first component is called view model, the second one is called LiveData, and the third one is called data binding. And I will explain each of them through an example as we move forward. Okay, so let's first see what this architecture looks like. And by the way, this slide is maybe one of the most important slides in the whole course. So what is MVVM? This idea of MVVM is that we break down our application into three main components. The first one is the view. So the view basically provides the user interface. Now let me just see the messages. Maybe there is some problem. Don't worry about it. It's recording also on my desktop. I will post it on YouTube. So I'm recording in both. Whichever works, it should be okay. So let's stay focused. Okay, so let me go back. What I want to say, my application will be organized into three major pieces. The first one is the view. Each piece has very clear role to play. So the view takes care of the user interface, and it allows us to get input from the user or display some data to the user. And whenever there is some change to this data that get displayed, we want to get updates about this data. For example, in here, take a look at this app here. You see where I'm putting my cursor, there's some piece of news there coming frequently. So for example, there are some matches going on, and this data change. Whenever there is change, I want this to be updated regularly. So I observe this piece of data. You see now it's changed. There's another team is playing, and this is the current result. So I really need my data, my user interface, not just to display information and keep it like that. I want it to be dynamic. As things change in the real world, I want my screen to pick up the change and give me the real-time information. This is very, very important, especially on mobile applications. It's a reactive user interface, a user interface that keep up to date as new data becomes available. Okay, so keep watch on this little text here. You will see it is changing because there are some new pieces of news coming in. and I pick them up and display them. Okay, now the data and the computation that the data that you display on this screen and the computation that is taking place whenever I do some change, the computation is taken care by the view model. So I don't store the data in the view. No data in the view, no data stored in the view, no computation, no logic on the view, only user interface related things. Who takes care of providing the data and notifying us when there is a change and get notified? The view model does this for us. Now the view model is not supposed to go to databases or go to the web and get the data. Who should go to the web and get the data? Who should go to the database and get the data? It is the repository. It is actually it is the model. And the model has two parts. It has the entities that store the data, and it has the repositories that read and write data from either a local database or a local file or from a remote server on the web. And we will see how to do this. Android gives us some very powerful components to do this. So to interact with database, we will learn something named Room, and there is another library called Retrofit. This is an open source library, not from Google, from some open source, but Google really recommend using it. So anything to do with data, reading and writing, summarizing, doing some work related to the data, who takes care of it? The model. So you can see here clear roles. If you follow this, what will happen if you follow this is basically what will happen if you follow this, you will get in one line, you will get maintainable and testable app. An app that is easy to understand, easy to change, easy to add more features, easy to fix bugs, and it's testable. You can test it more easily because each component is separate from the other. Okay, so now this is not theoretical stuff. This is not just blah blah blah. This is a real things. So Android around 2016, 2017, they released groundbreaking components that really helps us to build this MVVM based application. So this course now has radically changed. The course has changed really significantly. You are lucky that you have taken this course using this very sophisticated and very powerful technologies that hopefully you really appreciate. So there is something called Android Jetpack, and it comes with many components that we will see today. One of them is the view model, the LiveData, the data binding, and Room. So let me now switch to actual implementation and show you exactly what's going on here and the role of each one. So I'll come back to the slides if needed, but let's now jump into the actual implementation to show you what's going on. So let me first run this app. And let's super quickly move on with this. Okay, so while it's running, I just want to, okay. Here it is. Here's my app. Currently, it does nothing. It just has, let's imagine this is some commentator of a match. They are watching this match, and whenever there is a new goal, you click on this to increase the score. Now it's not working. If there is some new piece of news, it gets shown here. As the time goes on, this gets decremented until the match is over. So this is what I want to really do. Currently, it's not doing anything. For now, all what I have is, you should be already familiar with it. So the layout, this is my layout here. So this is my layout. So let us now quickly go and at least make these buttons work when I click them. When these buttons are clicked, I want to make them increment this value here. So let's do it quickly. So what I will do, I will simply declare two variables. So val team1 score equals 0 and val team2 score equals 0. Okay, this is the start of the game. Now what I will do here, I will say here team1, when this button is clicked, I will listen to it. I will listen to on set on click listener, and when this button is clicked, what I want to do, I want to take this team1 score and I want to increment it. So I need to make it var, not val, so I'll be able to change its value. So 2 vars, and what I will do with this new value, I will go to team1 score text view dot text equals team1 score to string. That's it. Now when this button is clicked, I will get that value. I will also initialize when the screen starts. I want to initialize my screen with this value, and I will do exactly the same for the second button. So I change 1 with 2. So hopefully this is super clear. Okay, so let me run. Hopefully things will work. So I am watching this on-click event, and basically so let me just, okay, just give me 1 second. All right, so here it is. Now it's working very nicely. Yes, so here's the match going on. Ryan is 2 and Khor is 3. Okay, and I put this complicated implementation here to do this. All right, so after all this effort, let me rotate my screen, which is something we do very often. So let me just, I want to see something here.
Doctor, are you recording from your side or what?
Sorry?
Are you recording from your side or?
Recording from my side.
Okay.
Don't worry about recording. Let's not corrupt the discussion by this. It's recording here. It's recording, so don't worry. All right. So are you following with me? So when I click these guys, these buttons, this gets increased. So Ryan, another score. Al-Khor, another score. But my problem is I suddenly rotate my screen. And look at what happened. All my hard work. What happened to my hard work? Can you see the scores? What happened to the scores? Any idea?
It got restarted.
It basically is lost. All my scores now, we don't know who is the winner. We have a big problem here. All the scores are gone. So why did I lose my scores? I did not do anything. I just rotated the screen. Do we rotate our screens when we use our phones? I think we do, yes?
Yes.
Unfortunately, all my data is now lost. So there's a problem here. So let me just make sure. Maybe I was just made a mistake. Okay, rotate. Gone. The information is gone. So how can we explain this? What's going on here? Okay, this explains it. If I watch the life cycle of the activity, this will explain it for me. When I rotated the screen, my activity was paused, then it stopped, then it was destroyed completely, and then it was recreated and resumed. So what happened here? What does this mean? Because it was destroyed and recreated, these values, the data I put in here was lost and reinitialized back to 0. Anything I put in the view Anything I put in my activity in the view is lost. Let me show you another configuration change that will make me lose my data. So you can see here, every time there is some configuration, let me put the scores back again. Here is the scores. Now let me go to my phone. Maybe this we don't do often, but sometimes it happens. Somebody changes the language of the phone, of the device. Here's the language. And I go ahead and change the language. Here's my languages. I'll change it to French. And take a look at this when I go back to my activity is now paused because it is in the background. My activity is not active, it is in the background, but it's still there. You can see it here. You can even see 3 and 4. But as soon as the app comes to the foreground, take a look at what will happen. My scores are gone. Again, what's going on here? I didn't even rotate the screen and my scores are gone again. What's going on here? Here is what's going on. When the language changed from English to French, basically my app or the activity on my app was paused. It was already stopped. The Android system destroyed it because of the language change and then resumed it. After it resumed, of course, a new instance of this class is created and these values went back to 0. So whenever there is a configuration change, either a screen rotation or a language change, let me change back the language to English. You see here, this is my score. I'll go back, change the language. Here's my language change. So once I change the language, where is it? Come on. Long, and then now we have to talk to it for French. Long. Okay, here is long is easy. Now change the language. Here it is. My application is now paused and stopped. Why is it stopped? Because it's in the background. It's no longer active. But it's still there. All the information is still there. Now I changed. If I go back to it without changing configuration, it should be fine. It's still there. No problem. I'll go back, change the configuration, put back the language to English. Okay, go back to the app. All the data is lost. Why all the data was lost? Because the activity was destroyed and recreated. Now, one bonus point, if somebody can answer me, why Android people do this? Is it just because they want to give us a hard time? Or there is some reason behind it? Why they recreate the screen or the activity?
If you want to change the style of the app.
What do you mean? More details.
For example, if you have a different theme for different orientations.
Not theme. I don't think
different
the theme
layout
will change. Close, but just try again.
Different layout?
Different layout. Thank you very much. That's it. If you can please just message me after this. Yes. Very, very nice. Because your app might have a different layout, one layout for portrait and one layout for landscape. That's why it recreates. Also for the language, remember the language? You can have strings that you show in here. You could have an English strings and Arabic string and French string. When you change the language, the whole screen needs to be recreated. Is clear? This is the reason. So they don't just do it for no reason. This is the reason, because each orientation of the screen might have a different layout, and each language might have its own resources. So that's why the activity is recreated every time the screen is rotated or every time the language changes. Now, how do we solve this problem of losing data? How do we solve it? So the solution is on this, Allahu Akbar, the solution in this view model. So we need to kick out all the data and all the computation to the view model. And the view model, which is given by Android, this is where we should put the data, this is where we should put the computation. And this component here survives config changes. If there's a configuration change, it will survive this configuration change. And also the view model is aware of the life cycle. When the activity is finally destroyed, completely destroyed, when the user closes the app, then it's fine. When it closes the app, then the view model will be destroyed. But if it was just a rotation, the view model will not be destroyed. So we need to use the view model to put our data and computation in there. So this is exactly what we will do. In this case, we have a simple computation, simple data and simple computation, which is just incrementing. So what I will do, I'll cut this from here. This is not the right place to put it. And I'll create a class, and I will call this class my view model. So here is the football view model. So it's just a class, just to save time. It's just a class, nothing in there. And what this class it does, it must implement this view model. This is the magical view model given to us by Android platform. So we must extend from this class. And here, no problem, let's put our data here. And let's put our computation in here as well. So I'll put here fun increment team1 score. And here all I do, team1 score plus plus. Of course, in the real world, I can have more complex computation, but in here I have very simple computation for now. Team2 score and team2 score. Okay, so the data and the computation is, we cut it from the view and put it in this view model. That's it. Now let's go back to our activity, and basically, of course, this is complaining now. Let's create an instance of our view model. So we'll call, here is the football view model. So I don't just go ahead and do, so here it is, val view model equals this. I should not just go and create it like this, because this will not solve my problem. When the activity rotates, this will be initialized back to this. I will lose this again if the screen rotates. So instead, I'll ask Android to give me an instance of this view model. So to do that, I can basically do something like by view models, and I'll ask it, please give me an instance of a football view model. I will explain this shortly. So what's going on here? I basically, instead of creating an instance myself, I ask Android, please give me an instance of this. So the first time I run this activity, it will create an instance and keep it for me. And then when the view is recreated, this same instance will be given back to me. So, and that's the trick basically. Android will keep this and will not destroy it when there is a configuration change. Now, what I can do now, I basically go ahead and read the data from the view model. And here, whenever there is some computation, I ask the model to do it for me. Increment score 1. And here I read it from the view model. So in the view, I only deal with displaying the data on the view. I don't deal with keeping the data. I don't deal with computation. So I don't keep the data here, and I don't deal with computation. I ask the view model to do the computation for me and to keep the data for me. Okay, that's it. All my data now is stored safely in this view model, which is nothing but a class that extends view model. That's it. And the other thing you need to keep in mind, when you create an instance of this class, you don't create it the normal way, equal. You ask Android, please give me an instance of this. The first time you run this activity, it will give you a new instance. Subsequent times, it will give you the previous instance that was already available. So let us run this and see, hopefully, if this has solved our problem or not. So let me just clear this. Let me just see my all right, football. I just want to give me 1 second, please. Just want to do a small change here, just to be able to watch this. Main activity. Just a second. Yep. Okay, why it is using main activity? Yes, okay, that's fine. Yes, I got it. Yep. I will just, don't worry about it, it's just a tag. I want to filter by this tag, which is football. Okay, so let me just restart my app. We just watch the life cycle of the activity. Let me clear this guy and take a look at what's going on here. So once my app starts, I can see, I will start seeing the life cycle of both the view model and the activity itself. Okay, so let me just, not sure what's going on. Let me just rerun it. Okay. All right, can you see here? So when the activity starts, a new view model is created. Also, the activity is created, started, and resumed. This is the life cycle of the activity. So just let me show you here. This is the diagram showing the life cycle. So first, it doesn't exist. It gets created, so the state is created. Then from created, it goes to started, and from started to resumed. And if it goes in the background, so for example, in here, if I switch to a different, if I switch to something else, my activity is paused and then stopped. So it gets paused and stopped, but it's still there live. And then when I go back to it, it will be resumed. So there is a life cycle that the activity goes through. So it is resumed. Now let us try, here is the match 3-1. And let's now rotate the screen. Here's the screen rotation. Let's put it to test. You see my score is still there nicely, no problem. The activity was recreated, destroyed and recreated, but I never lost the data. Why? Because the data now and the computation is pushed to the view model. And the view model, as we've seen here, the view model survives configuration change. If there's any configuration change, it does not get affected. So let me clear this and let me rotate again, the activity will be recreated, but the view model was never recreated. It will be there until the activity is closed. If I go ahead and close the activity, then you can see the view model will be cleared, and the activity, of course, will be destroyed. So the activity might go through multiple recreation cycles, and it will still use the same view model instance. So my data will never be destroyed on configuration change. So I hope it's clear. Now, the second thing I want to show you, take a look at this. This is the full app. Let me just run it. The full app has more features. Now I will not demonstrate step by step. I will just give you the idea. You will go to the lab, apply it, and the next time, inshallah, I will explain it. So I hope the view model is clear. So which app is this? Okay. All right, so is this the old or the new? Okay, which one I'm running? Okay, so let me run, yes. Why is this? Okay, this is the start. This is the full implementation. Let me just try it again. Okay. So hopefully this will start changing, hopefully. And also I should see some piece of news here coming. Yes, this is starting to change. Can you see it? It is counting down. As the time goes on, this gets changed. And also there are some other matches going on here, and I can see some news coming. Bayern Munich is 3 and Real Madrid is 4. There's some match going on. And later on, this will be also refreshed again. So a lot of things here is going on here. There is some data coming from the outside world, and it's getting refreshed. Can you see it? And now there is another match going on, and this is the results. So this is my screen. When I open it, it does not just show me the state when that screen was open. It keep on bringing me updates as the data behind the screen change. So watch this part here. You will see it changing, and watch this part here. You will see it changing. So this is the trend now. When I write an app, I need this app to be reactive. Whenever there is an update from outside, from some piece of data that I'm watching on the web, or some data that I have on locally on some kind of database, whenever it's changed, I need that change to be reflected on my screen real time. And this is where another component that comes with Android helps us to achieve this. And this component is called LiveData. So LiveData is a very important pattern used in user interfaces, whether on the web or on iOS, Apple iOS, or even for desktop applications. Those of you who have written some code in JavaFX, you definitely have seen this pattern. It's called the observable pattern. So what happened is, this is exactly the same as in the real world. See, in the real world, we have some some celebrity and some fans. So the celebrity, they might have a Instagram account or a Twitter account. Whenever they have some new piece of news, they will post it on that platform, and that platform will push these notifications to the subscribers or to the observers. So exactly the same thing here. We have a live data, which is the observable, and we have the UI watching this live data. Whenever there is a change, the live data will push the change to the UI to get displayed. This is exactly what live data is. It is an observable, and the UI observes it, and if there is any change, it will be reflected on the UI. So exactly what's going on here. Whenever there is a change, the news will be updated and the time remaining will be updated. Okay, in this case, I think it does so every 10 seconds. All right, so see here it changed, and this, after another 10 seconds, it will change. Okay, so let me now show you how this is done exactly. Very simple. All I do, by the way, if I have some piece of data that is changing with time, I go and I wrap it inside a live data object. And then on the UI, I start observing it. Whenever there is a change, I react to that change. And that's it. That's the idea. So let me show you what this means concretely. Here it is. So if I go to my view model, here is my view model. Here is the data. Now, the data before, if you remember, when I first created, it was an int. If it is just, sorry, I meant it is an int. If it is just an int, it's not that useful. Basically, I can store some values in there, no problem. But I cannot watch it. I cannot get it to notify me when there is a change. So if I really want this to become an observable and people can subscribe to it and observe it, instead of declaring it as an int, I declare it as live. If I just declare it as a live data, then people can watch it. But because I want to also, because this is the view model, I can change it, so I can call it a mutable live data. So this is changeable.
No.
So what is the problem here?
Just the equal, Dr. Ross.
Okay.
Instead of colon, equal.
Equal, yes, thank you very much, yes.
Yeah.
Okay, so that's it. So instead of using a normal int, I use live data. Once I do that, now when I increment a value, I cannot just go ahead and put the value like this. I no longer can do this or do plus plus. This is not a normal object. What I can do, I have to take and post a new value. When I post a new value, basically the subscribers or the observers will receive this update. So it's very simple. All I do, instead of using a normal data types, I use the data type, but I wrap it. You see here in my slide, I wrap my team score into live data. And then it becomes observable. Whenever there is a change, I do this. I can do this way, or I can just do post. I used post here for you to be clear, to be very clear in your mind that I'm not just changing the value, I am posting the value so the observers will get notified. Now, how do I observe? How do I observe the changes here? Very simple. So if I go to the activity, here is my activity. All I do, let me show it to you. So I'll go here, view model dot this. Now let me, before I show you this, let me show you just very common pattern, the way we write it. The way we write it, we make the mutable version, the version that is changeable, we make it private, and we call it with underscore. This is just a convention. And then we expose it as live data. So the outside world can subscribe that they cannot change the value. So inside it is mutable live data. To the outside world, it is live data. And the convention is to give it the same name, except for private one you put underscore, and for public one you remove the underscore. So what I mean here, if I come here, I can observe this. I can observe, and I will say this. It is observed. This live data is being observed by this, and then I can do no, because in here I am in a fragment, so I need to pass the activity. I need to pass the activity because the activity could be null. So the fragment has a method called require activity, and this is, don't let this confuse you. This basically, if it is, it gets the activity. If it is null, it will throw an exception. So basically, require activity, it means that this score is being observed by the activity on which this fragment is loaded. And then I'll get the value here. So I can do here debug log.d tag, and then I can put it. This is the new value. Because this is an integer, I convert it to a string. This is how I observe it. That's it. I can, of course, go ahead and change the UI. I can go here and say team1 score text view dot text equals it, which is the new value that came from the view model, dot toString. I can, of course, go ahead and change the UI using this way. But there is, so I hope it is clear. So let me just summarize it one more time. So in my view model, instead of using a normal data types, I wrap them into live data. Why do I wrap them into live data? To be able to observe them from the UI. In here, this is how I observed it. I basically say, you are now being watched by this activity. Let me know whenever there is a change. When there is a change, I pick that change. In this case, I'm just logging it to the console, or I can pick that change and update my UI. Now, there is another more sophisticated way. Instead of writing the code to update the UI, I can link the UI directly with this. I can link both directly without writing code like this. So how do I do that? So let me show you the UI. Here is the fragment for the football. So all I do, here is my team one score. Team one score. All I do, I go to this property text and I put this ampersand curly brace, and I go to my view model team one score dot get value. Okay, and because this is an integer, I convert it to a string. So with this line here, my view is now connected with this live data. Whenever it changes with zero coding, that change will be reflected here. The only thing I need to do in the layout, instead of this one being the root layout, the root of the layout, my layout is wrapped into another XML element called layout. And in here, I declare my view model here. I declare it. Yeah, I declare it here. And then I can access it in the properties. So for the team2 score, I do the same thing. The text of this text view will come from the view model team2 score get value, and I basically show it like this. Maybe I think it's asking me, maybe I can just do, because I am here in Kotlin, I think I can just do dot value. Yeah, okay, it still didn't like it. It doesn't matter. Okay, now let me show you the other one, the piece of news, how the piece of news is coming. Here's the news feed. So this is a live data coming from the view model, Whenever it's changed, I display it directly on my screen with zero coding. So let me show you this news. What is this news? So if I go to my view model, here's my view model here. The news is nothing, it's some pieces of news coming from the repository as a live data. As long as it is live data, once I bind my UI to it, any change will be automatically reflected. Now, this is coming as a stream of data. We will see how to do this later on. For now, don't worry about it. But don't worry about this part. We will learn it later on. For now, it is just a dummy data that is being pushed in an infinite loop every 20 seconds. And basically, this live data is coming to my model, and I take it and connect it with my user interface, directly connect it with my user interface. Same thing with the time remaining. Time remaining is also live data. I connect it directly with my user interface. So this is called binding. So let me show you a picture of this so it's clear in your mind what binding really means. What binding means, what I'm doing is I'm basically connecting this text view to some object, property of an object. Whenever this property change, the text will be automatically synchronized. So this is what binding means. By the way, it could be one directional, which means whenever the username change, the text will change. Whenever the piece of news change, this text will change. Whenever the time change, this text will change. Okay. Now it could also be bidirectional, like in here. I could change whenever I change the name, whenever it changes on the object, it gets reflected on the UI. And whenever it changes on the UI, if I change this to and change the years of experience, this is now changed in the object as well. So if I go to my, you can see here it changed in the object as well. So not only changed on the UI, any change in the UI is reflected on the object. So the binding could be either unidirectional from the object to the UI, or it could be bidirectional. If the UI change, it gets reflected on the object and vice versa. So I know it's a lot of things, but this is how we do it in this course. We throw ourselves into the water, go and play with this in the lab, come back for more clarity in the next session. So let me just summarize the whole thing that I discussed. This is definitely the most important session in the whole course. What will come next in the remaining of the course, we will be basically trying to achieve this model view MVVM. We will build our applications from now on following the Model-View-ViewModel architecture. And Android comes with some very important features and components that will help us deliver our applications following this nice architecture. So it gives us the view model where we can store our data and put our computation. And it survives change. If there is a rotation, I don't lose this data. The other thing I can do, I can wrap my objects or my variables. I can wrap them in live data, and suddenly these variables become observable. I can watch them. I can observe them. If there is any change, the UI get notified. Now I don't need to write any code if I want to do this watching. I can basically from the UI layout, the XML layout, I can basically directly connect it with I can directly connect it with my objects. And if this object happens to be live data, then any change will get reflected on my UI with no coding. Declaratively, this will be done. That's it. This is the idea. Hopefully, you get the glimpse of it. I don't expect you to really understand it deeply. It will click with the time and with the practice. So believe me, with this basic understanding, go to the lab, try to apply this, go through the slides again before you go to the lab. Look at the examples, play with it in the lab. You come back, inshallah, next week. It should be much, much clearer. Okay, thank you very much. Inshallah, in 10 minutes, we just go and pray and then we'll resume in the office hour.
Assalamu alaikum.
Yes,
Sorry, Doctor, I
walaikum
have just one question.
Yes.
Could you please go back for the white screen that?
Where should I go back? Sorry.
Yes, this one. The mirror. Yeah, this one.
Yeah.
I want to ask about the live data. If I use the live data in my application,
Yes.
do I have to use also the view model?
Do you have to use the view model? Okay, let me see. Like, remember, why did we add the view model to our app?
To avoid losing any data when the configuration of the app is changed.
Yes, very good. That's it. So from now on, no data should be stored in the activity or fragment. So every time I create an activity or fragment, I'll go ahead and create a view model to place the data and computation in there. So the host where I'll be hosting this live data, where I'll be putting it, I'll put it in the view model, definitely. So I'll put it in the view model, and then I can observe it from the fragment or from the activity. Either directly, either through code or through binding. So I can observe this. So I can observe this, either directly through code or through binding. Yes, I must use the view model. Not only because I need to host my live data objects, but also to survive configuration change. I don't lose the data. Otherwise, if I don't use the view model, I'm giving myself a hard time. In the activity, I have to basically, I have to detect that there is a configuration change. Before the configuration change happens, I will store my state or my data in a file or a database. And then when the activity resumes, I have to retrieve it. It's a lot of work. So why should I give myself a hard time? Just create a view model, put the data in there, and if there's a configuration change, Android gives me guarantee that my data will still be there.
Yeah, thanks. Yeah. Thanks so
much. Not only this is a pattern. When you use your application, you must respect this pattern. Otherwise, don't call your application MVVM based app. It's a spaghetti app or an app or khalas. It's not really designed using the best practices. The best practice, and you can see it here. If I go here and just Google it, MVVM. It's so famous, so popular. Take a look how many hits in here. Even Wikipedia knows about it. Heavily used, not only on Android, on iOS also, on web, on desktop. Basically, whenever you have a UI type of experience, you use MVVM architecture. And the concept you learn, this is the nice thing about this course, the concept you learn and practice here, if you have the opportunity to do it on Android or on the web, it will be the same concept. Different implementation, slightly different implementation, but same concept. The view takes care of the UI, the view model takes care of the data of compute and computation. The model handles the data operation. You must respect this role and give every component the role it is specialized in. So I hope it's clear. So even if it is possible to put the live data object and declare them in the view, never do that. Put them in the view model from now on. Khalas, there is no more data and computation on the activity of fragment. Okay? All right, so inshallah, let's break an idea about the midterm questions. Okay, the midterm questions, I haven't prepared anything. The midterm question is basically, they will be explain, compare. You might be given, especially for Kotlin, you might be given some piece of code, let's say using loops. I'll ask you to convert it to using lambda expression, for example. Give a scenario of usage, give an output of some small piece of program, especially for Kotlin. So I will give maybe some small example questions or where to focus more as soon as I prepare the exam. I have not prepared it yet, but usually my exam style is like this. Explain some concept, compare it with another concept, highlight the advantages, disadvantages. For example, one thing that comes to mind as an example, let's say in the layouts, in the constraint layout, if you remember, we have seen something called barrier, and the other one is called, what's the other one? There is a barrier and there is, sorry, just give me 1 second. There's something in the constraint layout. Here it is. Here it is.
I think it's the helper, Doctor.
Yeah, the helper. Yes, this is guideline.
Guideline, yeah.
For example, these are the type of little questions that basically what I will do when I prepare my exam. I'm just giving you the secrets. I'll go through the slides again, and I'll find some tricky little things. Compare this with this. Explain this. When to use this versus when to use that. For example, I might ask you, what is the difference between guideline and there is something called barrier? Give a small scenario when you use each one as an example. Okay, these are the type of questions. So as I go through this exercise, I might give some tips as an announcement. But believe me, if you really go through the slides and understand them, if you have been practicing, it should not be a big deal. For example, I might ask you why, give you two screens, when the screen is rotated, I lose this data. Explain why, what's going on here, and how to solve it, as an example, okay? So conceptual concepts, ideas, major ideas. I will not ask you about little syntax, for example, what is the attribute I use to change the size. Even me, I don't know it, it's not important. I'll ask you about the ideas. I will never ask you, for example, which attribute do I use to change the text or change the color, or that's not the idea of the test. Is concepts. So focus on concepts, focus on ideas, focus on being able to compare related concepts, being able to understand when to use what, being able to give small examples, being able to convert from one style of code into another style. So the code is in front of you. You just need, for example, I give you a loop and you convert it to a lambda expression, for example. These type of things. So once I go through the exercise of preparing it, I will give you some further tips. All right, any other question? So all from the slides. From the slides, explanations, from the practice that you have done. So if you understand what's going on, if you have been practicing, it shouldn't be a problem at all. It should not be a problem. Okay. All right, inshallah. So let's break for now, and we'll resume at 10 past 12. If you have any questions, we can discuss them, inshallah. Okay, thank you very much. Let me just